All right. Good morning, guys. Of course, I guess if you're not watching this in the morning, I should say good day. Uh, this is Mrs. Lyons, and this video is going to take you through the concept of limiting reagent or limiting reactant. Okay. And the definition of a limiting reactant is a reactant in a chemical reaction that determines the amount of product that is formed. Okay. Put simply, it is the reactant that runs out first. Okay. So we're going to look at um, an example and kind of walk through this process, what you will see in a problem. Okay. So, for example, this reaction says we're reacting nitrogen gas and hydrogen gas to form ammonia gas, NH3. All right. The question says how many grams of NH3 can be produced from the reaction if we start with 5 grams of nitrogen and 5 grams of hydrogen. Okay, so if you remember, the reason that we use moles is because 5 grams of hydrogen and 5 grams of nitrogen do not contain an equal number of atoms or molecules. Okay, so what we have to do is we have to do 2 gram to gram stoichiometry problems. Okay, so for example, find the grams of product formed for each reactant. Okay, so we're going to do 2 gram to gram calculations. My first one, I'm going to start with 5 grams of nitrogen, N2. Okay, and I want to figure out how many grams of NH3. Okay, so it's going to be a 3-step problem. All right, so I will put in this first step, I need to convert grams of nitrogen to moles of nitrogen, okay, using the molar mass. So we have nitrogen, 2 nitrogen, so that's going to be 28.02 grams of N2. And that is equal to 1 mole of N2. So that's what the molar mass is. 1 mole of nitrogen is equal to 28.02 grams. Let me grab my calculator. And we will see 5 divided by 28.02 is 0.1784. And I'm going to carry a couple of digits, 0.1784 moles of N2. Okay. I'm going to kind of divide this down the middle. So now I'm going to use the moles of N2 to determine the moles of NH3 I can make using the mole ratio with the balanced chemical equation. So 0.1784 moles of N2. I'm going to use the mole ratio. So moles of N2 goes on the bottom, and moles of NH3 go on the top. All right, so if I look at my balanced equation, 1 mole of N2 reacts with 2 moles of NH3. So if I calculate, I'm going to get 0.3569 moles of NH3. Okay, now we want to figure out how many grams. Okay, so now we have to use the molar mass of NH3 to convert to grams. So I'm going to go 0.3569 moles of NH3. O is over 1. And I'm going to use the molar mass, but this time moles go on the bottom. And NH3, let's see, nitrogen is 14.01, hydrogen is 1.01, so 3.03. The molar mass of NH3 is 17.04 grams. All right, so I plug that into my calculator, and I get 6.08 grams of NH3. So this is the number of grams of NH3 that can be made if I don't run out, if I use up all of my nitrogen. Okay, so now we're going to do the same type of calculation, but this time we're starting with 5 grams, it should say 5 grams of H2. All right, so try to fit this in here. 5 grams of H2. All right. Since we're starting with H2, we're going to use a molar mass of H2. So 1 mole of hydrogen is 2.02 grams of hydrogen. So I'm going to do 5 divided by 2.02. I get 2.4752. 2.4752 moles of H2. All right, I'm going to use that in my next step. So 2.4752 moles of H2. In this step, I'm using the mole ratio. So saying if I use this many moles of H2, how many moles of NH3 can be produced? So 3 moles, for every 3 moles of H2 used, 2 moles of NH3 can be produced. All right, so let's plug this into my calculator. Times 2 divided by 3, and I get 1.6501. 1.6501, and that is moles of NH3. Okay, so now we have to calculate grams of NH3. So we're going to start with 1.6501 moles of NH3. And we want to figure out how many grams of NH3. And if you look, the last step in this problem is exactly the same. Okay, the conversion is 1 mole of NH3 under 17.04 grams of NH3. So let's see. If I do that math, I get 28.12. Okay, so now here's where we go beyond the stoichiometry. Here's where limiting reactant is determined. Okay, so what this next step is it says determine which of the reactants is the limiting reactant. Okay, the limiting reactant is the reactant that produced a smaller amount of product. Okay, so we're going to compare 6.08 grams and 28.12 grams. So 6.08 is smaller. So the limiting reactant, now don't write down NH3 because that's the product. All right, we have to look back at the beginning. We started with N2. So we are going to run out of N2 first. So the limiting reactant is nitrogen. Okay, because it produces once 6.08 grams of ammonia is produced, the reaction will stop because there's no more nitrogen to react. Okay, if we had more nitrogen and we wanted to react all of our hydrogen, we could actually get to the point where we produce 28.12 grams. But in this case, we run out of nitrogen. Okay, now determine the excess reactant. Well, there's only 2 reactants in here. So one is the limiting. If N2 is limiting, then H2 is the one that is in excess. And then the theoretical yield, you've already calculated the theoretical yield. The theoretical yield is 6.08 grams of NH3. Okay, that's the amount that should be formed if all of our nitrogen is used up. All right. So I'm gonna actually do another example for you. All right. And then I will have you guys do the other 2 examples on your own. All right, so here we have another equation. This equation is we're reacting sulfur and oxygen to produce disulfur trioxide. All right, so this is how many grams of S2O3 will be produced if 6.3 grams of sulfur is reacted with 10 grams of oxygen. Okay, so what we've got to do is we start with 6.3 grams of sulfur. Okay, and we're going to do a gram to gram problem. Okay, so a 3-step problem. Use my black pen. Okay, so we're going to first thing we have to do is convert grams to moles using the molar mass. So the molar mass of sulfur is 32.07 grams. That's on the periodic table. And that's equal to 1 mole of sulfur. Okay, so if we do this math, 6.3 divided by 32.07, I get 0.1964 moles of sulfur. Okay, now we need to convert from moles of sulfur to moles of S2O3. Okay, so we start with 0.1964 moles of sulfur. We're going to use the mole ratio. All right. So I had misbalanced the equation. So notice I changed this to 4 moles of sulfur to produce 2 moles of S2O3. So in our step converting from moles of sulfur to moles of disulfur trioxide, for every 4 moles of sulfur, 2 moles of S2O3 are formed. Okay, so if I do 0.1964 times 2 divided by 4, I get 0.0982 moles of S2O3. All right, now the last step is to convert moles to grams. So 0.0982 moles of S2O3. We're going to use the molar mass, so 1 mole of S2O3, and then I've got to calculate. So sulfur is 32.07. 3 oxygens would be 48. Let's see, 7, 8, 9, 10. So 112.14 is the molar mass in grams of S2O3. All right, so times 112.14 equals 11.01 grams of S2O3. All right, so this is how much S2O3 we can produce if we start with 63 grams of sulfur. Now we have to do the starting with 10 grams of oxygen. So we got to go through the same steps. So starting with 10 grams of oxygen, we have to convert to moles of oxygen. So O2, molar mass is 32 grams. That's equal to 1 mole. So 10 divided by 32 is 0.3125 moles of oxygen. All right, next we need to use the mole ratio to convert from moles of oxygen to moles of product. So let's look at our balanced equation. For every 3 moles of O2, 2 moles of S2O3 are produced. So I'm going to do times 2 divided by 3.2083. And that's moles of S2O3. So one more step. We've got to now convert to grams. So 0.2083 moles of S2O3. This is where we use the molar mass. And the nice thing about limiting reactant problems is we've calculated that molar mass already. We just need to use it again here, 112.14 grams of S2O3. So I'm going to take this times 112.14 and, my calculator, 0.2083 times 112.14 equals 23.36. And I ran out of room. Let's put this down here. 23.36 grams of S2O3. So what we've got to compare is we've got to compare the amounts of S2O3 formed. Okay, since starting with sulfur, we form fewer grams. The limiting reactant is sulfur. And the excess, that means the excess is going to be oxygen. And I didn't leave a place here, but if I wanted to know what the theoretical yield was, whoops, sorry, you can't see that. The theoretical yield would be 11.01 grams of S2O3. All right, so I hope that makes sense. I hope that helps you see what we're talking about when we're talking about limiting reactant. I will see you in class. Take care of yourself.